So I'm going to start off by inviting Emma Carter, to come and give the first presentation. So Emma is a clinical research fellow doing her PhD here in Department of Clinical Sciences on human challenge and TB. So over to Emma.
Hi, my name's Emma, so clinical PhD student here, and I'm going to present my work on developing a human challenge model for tuberculosis to accelerate vaccine development. So, the BCG vaccine is over 100 years old. It's the only licensed vaccine for tuberculosis, but has limited effectiveness. Clinical trials in TB vaccine development are notoriously problematic, because there is no established immune correlate of protection as with other diseases. And therefore, the process of developing a vaccine is expensive and involves lengthy timelines. Controlled human infection models involve giving adult volunteers, deliberately giving them an infection in a controlled environment. And they've been used for other diseases to test novel vaccines and therapeutics, and can compared to conventional studies, so conventional clinical trials, they involve fewer participants and they are rapid, so could be used to accelerate vaccine development and have been for other diseases. So the Liverpool Vaccine Group have been developing a TB-controlled human infection model. And we've used BCG as a surrogate challenge agent. So this contains live Mycobacterium bovis. And we inject participants with this intradermally at up to 4 times the dose. We then take skin samples to monitor BCG growth, as well as nose and blood samples to monitor the immune response. So in the context of vaccine development, my question for the panel is, how do we contribute to stemming the tide of anti-science and anti-vax movements? Thank you.
Thank you very much, Emma. We're going to have some challenging questions for the panel coming up, but I'm going to move on now and invite Rachel Clare to give the next presentation. So Rachel Clare is in tropical disease biology. She's, I think, the longest standing member of LSTM on our group of speakers this afternoon, 14 and a half years. And actually this week is her last week at LSTM, so very fitting that you are giving a talk today.
Okay, so thank you very much for listening to me talk today. So I'm going to talk to you about Galeria melanella as an alternative model for snakebite. So I'm sure you've all heard Nick's talk yesterday that snakebite envenoming is a serious and neglected tropical disease. Around 100,000 people every year die from snakebite, and 4 times that many people actually end up permanently disabled. Conventional antivenoms, though, have a lot of limitations. So you have frequent adverse reactions, you require a cold chain, reliance on intravenous injections, so both these mean you have to be given your treatment in a hospital setting. The antivenom is specific to the venom it's immunised against, and it's also very expensive. So a lot of work is now focusing on looking at alternative improved therapeutics, but these all require preclinical models that are validated by the WHO, which require a large number of mouse to be used annually. This is both in and standard antivenom manufacturer's process, but also in any new therapeutics that are developed. So my work is whether we can see if Galeria melanella could be used as a beneficial alternative model in this context of antivenom manufacture or actual research into new therapeutics. So Galeria melanella are a larvae from the greater waxmoth larvae, of the greater waxmoth, and they have a lot of benefits in their immune system is very similar to that of vertebrates in their innate immune system, and they have a lot of physiological similarities. But great benefit to the potential snakebite field is that they are low cost and low labour intensive. They also have no requirement for specialist equipment and no ethical licensing is required, and they can be maintained at human relevant temperatures. So we can use these in settings to help fast track some of the development of processes that we need for any laboratory across the world. So I've been given an NC 3 hours project grant for over the next 3 years at Edge Hill. I'll be leading that to try and develop a model alongside my collaborators at Lancaster University, University of Liverpool, University of Exeter. And this model we're hoping will then go into ICP's antivenom manufacturing process out in Costa Rica. So my question to the panel is, considering alternative approaches, how will our global communities embrace artificial intelligence to deliver our future needs? Thank you very much.
Thank you, Rachel. Another big ticket question. So next up, we've got Katie Davis, who is a new postdoc here, working on background in gender inequity and working on AMR. So welcome, Katie.
Thank you. So today I wanted to pose a question about how we target health interventions in relation to challenges such as climate change and AMR. In my PhD, I started out looking at the health impacts of climate change in communities in the Arctic. But what became increasingly apparent during this process was that it's actually these really deep-rooted inequities within society that are ultimately shaping the specific impacts of health that people of climate change on health that people experience. And also other disasters. And these are structural processes in that they relate to how power and resources are shared within society at multiple levels. So I now work in the Gear Up Consortium, and we're looking at the gender and equity dimensions of AMR. And it's interesting that it's these similar deep-rooted inequities that we're seeing that are influencing many dimensions of AMR. And this includes susceptibility and exposure to resistant infections, access to antimicrobials and healthcare, and the social impacts of living with AMR. So, for example, in many contexts, women are particularly exposed to resistant infections due to domestic care roles. Refugees may face particular barriers to accessing diagnosis and prescription of antibiotics. And those in specific occupations in close proximity to animals also face specific exposures. And this means that many current approaches to surveillance and interventions are only addressing the tip of the iceberg, as you can see here, and they're not necessarily reflecting or addressing the structural drivers of AMR or the complex social inequity processes involved. So given the major influence of these structural inequities in global health, my question to the panel is, how can we best develop interventions that address the structural root causes of ill health and disasters? Thank you.
Thank you, Katie. So next up is Richard. So Richard completed his PhD here, I think, last year, on part of the MRC DTT programme, and in his first year as a postdoc on AMR. So over to Richard.
Hi, I'm going to talk about bacterial isolates in neonates in Tanzania. We all have our microbiome. I don't know what it looks like after that lamb kofta there, but generally in a healthy microbiome, you've got commensal organisms that are beneficial to human health. But in certain places, there are many variables that can affect the mucosal intestinal barrier. Things like HIV, malaria, malnutrition, these can affect neonates in places like Tanzania, and this means that bacteria can translocate from one side of that barrier, the gut, to the blood. Then those bacteria will go round your bloodstream, and then this can elicit a response from your immune system, which can end in sepsis, which is fatal and life-threatening. So we were interested in the origins of bloodstream infections in neonates from Tanzania. So we took bacteria from the gut and the blood, and then did some genomic analysis to see, are these the same? And we used phylogenetics, average nucleotide identity, variant calling, virulence genes. But we also looked at hybrid assembled genomes, which are these really high resolution genomes where you use long read and short read genomes together. And that allows you to look at structural and contextual differences between the two. And with that, we were basically able to show that E. coli and Klebsiella did translate from the gut to the blood and cause these bloodstream infections, which has lots of implications in bloodstream infection pathogenicity. So one big aspect of treatment of bloodstream infections and one challenge is antimicrobial resistance. So my question to the panel is the use of the term antimicrobial resistance a barrier for effective management of pathogen resistance? Thank you.
Thank you, Richard. So next up we have Shri, Dr. Shri Hedge, in the Department of Tropical Disease Biology, working on the AWOL consortium. Has been with us for about 4 years, I think. So over to you, Shri.
Hi everyone, I'm Shri Hegde, a postdoc from TTB, and I'm currently working on developing new diagnostic tools and treatment for lymphatic filariasis. So we know that LF is a major global health burden. And it's responsible for a leading cause of disability induced by the infections. And also, if we look into the development of lymphedema, there are a few molecular markers like lymphatic dilation, skin thickening, and also the increased circulating lymphangiogenic molecules that contribute for developing lymphedema in LF patients. The major question here is, can the lymphedema induced by the LF can be pharmacologically targeted or not. So we are funded by MRC in program grant, which aims to evaluate whether targeting oxylipins can be used to treat the lymphatic disease induced by the LF. So in collaboration with MRC, that is the Metabolic Research Institute here at University of Liverpool, we have developed a multiplex targeted LCMS-based quantitative assay that can quantify 96 different oxylipins simultaneously in biological samples. So we used this platform to quantify the oxylipin profile in the lymph nodes collected from the mice that's infected with B. malayi. And we found that there is a lipid storm in these local lymph nodes, possibly contributing to the lymphatic disease. Further, we used different pharmacological inhibitors that target the oxylipin synthesis pathways. For example, xyluton, which inhibits the synthesis of oxylipins produced by phylox, whereas cataprophene, which inhibits the production of oxylipins by both COX and LOX pathways. And we found that using our leg pathology lymphatic infection model, the treatment of this pharmacological inhibitor resulted in decreased lymphatic disease. And in addition to this, we also saw that the treatment also reduced the recruitment of alternatively activated macrophages that are previously implicated in the disease development. More importantly, we also saw that the treatment reduced the oxylipin contents in these local lymph nodes, possibly correlating with the decreased lymphatic disease we saw in the animal model. These demonstrate that, yes, filarial lymphedema can be pharmacologically targeted by targeting the oxylipin pathways. And we aim to, in coming years, to develop a safe and affordable treatment to treat the lymphatic disease using oxylipin targeting inhibitors. Coming from low middle income countries, which is endemic for multiple NTDs, my bigger question to the expert panel here is whether NTDs can be really eliminated. Thank you.
Thank you, Shri. Another tricky question. So next up is Hanafi Ismail. So Hanafi is a chemist who's been working in the Department of Vector Biology for the past 11 years and is now on our career track program. So over to you, Hanafi.
Thanks. Yeah, thank you very much. So today, I will share insight into the chemical biology of insecticide resistance, where chemistry meets biology to address growing challenges of insecticide resistance and disease vector. At the chemical biology group of, damages. Oh, sorry. What's happening? Sorry again. Sorry. Yeah. Yeah. Can you please put the slide back again? Yeah. So I believe that the majority of the audience here in this room agree that the mosquito resistance is not determined by genetic, while genetic diversity of the malaria vector is quite high. That's the lesson learned from 1,000 genome. And resistance influenced at the operational level by many factors, but on the flip side, the mechanistic factors that including genetic mutations like knockdown resistance, overexpression of metabolic resistance genes also play a major role. But it is not just the gene or the genetic informations of resistance involves crossing multiple biological barriers to reach the interactome where the insecticide acts. So at the interactome level, the chemical biology, the chemical interactions are critical and hard to predict in resistance, and they need further research. In dual AI formulations like chlorophyll pair and pyrethroids, antagonistic and synergistic effects can affect bioavailability and efficacy. So the industrial partnership led by the IVCC are driving the development of dual AI products, but these require careful optimization to target resistance population effectively. So here at LSTM, we are developing the insecticide resistance prediction platform. And the platform is about the collaboration with a global leader in resistance research at VBD, as well as fostering the strong connections with African partner, industry stakeholder, and IVCC. IRPP employ, as you can see from that slide, IRPP employs innovative analytical technology to unravel the interstate chemical interaction at the species and the molecular level, providing deeper understanding of the insecticide mechanism of mode of action. By integrating biological and chemical data, including insecticide pharmacokinetics, the platform aims to identify resistance factors that could impact new chemical intervention, enabling the prediction and mitigation of resistance to the next generation. Having said that, level of complexity and diversity in mosquito resistance is really high. My next question to the panel: are the Frankenstein mosquito that the answer to vector-borne disease? Thank you very much. And sorry about forgetfulness.
Thank you, Hanafi. I'm not sure Frankenstein mosquitoes is something that, well, let's see what the panel says. So next up is Jess Jinks, and Jess also completed her PhD through the MRC DTP program last year and is in her first year and a postdoc on anti-malarial drug discovery. Welcome, Jess.
Hi, everyone. So I'm sure you all appreciate the real clinical urgency to eliminate malaria. And one of the challenges to this that I wanted to speak about is relapsing malaria. So this is malaria that is caused by the species Plasmodium vivax and avali, and it presents a really significant risk to the eradication strategy. So it's characterized by the formation of dormant parasites in the liver, and these can reactivate at any point to cause a new and active infection after treatment. So in 2017, 3.3 billion people were living in P. vivax endemic regions. And this gives us an unquantified asymptomatic pool of people that can reactivate at any point and require treatment. So it's really important for us to not just be developing new treatments, but to be trying to preserve and understand the treatments that we have already. And this is exactly what we're trying to do here at Liverpool School of Tropical Medicine. And we have a really interesting new project, which is a consortium of a lot of different organisations led by the University of Liverpool, where chemists have identified some really exciting molecules with exceptional anti-malarial potency. And what we're trying to do here at LSTM is to try and characterise the enzymatic potency of these compounds. So this is just an introduction to the project. You'll be seeing a lot more, so keep your eyes peeled about that. And then in terms of understanding the treatments that we have got already, primaquine and tafenoquine are licensed for use against relapsing malaria. Sometimes they work brilliantly and sometimes they don't work so well. And in my PhD, I was trying to understand how these molecules work and how they might work with different combination partners and how we can improve them in the future. I spoke to a few of you at my poster. That was really great. Thank you for coming along. But if you have any more questions, I'll be at the CDD stand in the break. And I'd love to speak to you about how we've been exploring the in vitro pharmacology of the ataminoquinolone compounds. And on to my question. It's quite a broad question, but I'd like to ask, what are the key evidence gaps in future-proofing for pandemic preparedness? Thank you.
Thank you very much, Jess. So our final speaker on this panel is Dr. Micah Seekles, who is got background in adolescent mental health and's been with us for about 3 years, I think. So welcome, Micah.
Thank you. So my name is Micah. I've just started my DCF on designing a school-based mental health intervention in Liberia. Oh, I'm going the wrong way. So from birth to midlife, only around 20% of us will have enduring mental health. So that means that only 20% of us will have no significant periods of distress. This means that having at least one episode of impairing mental health difficulties is the norm rather than the exception. And in LMICs, it's estimated that around 1 in 4 people has a mental health condition in any point of time. And these rates are higher in people living with physical health conditions or those affected by conflict. And around 80% of people living with a mental health condition reside in LMICs. However, they are often undiagnosed and undertreated. So there's a complex relationship between mental health and other cross-cutting issues such as poverty and violence. And there's a bidirectional relationship between mental health and health conditions such as malaria or HIV or TB. So poor mental health complicates the management of these diseases. And it negatively impacts on health-seeking behavior, medication adherence or treatment adherence in general, and people's engagement with preventative measures. So, for example, whether they even sleep under mosquito nets. And instead, it often puts people at a higher risk of contracting illnesses. So my research and that of the Mental Health, Inclusion, Entity and Disability Research Group, not a full mouthful, as you heard this morning, we use participatory approaches that center the voices of people with lived experiences. For example, we often use co-researchers, which are people affected by mental health conditions, or NTDs, for example, who are involved in the study design and data collection. And we often use creative methods, such as photo voice or storytelling, which allow participants to express their experiences in ways that they often find less intimidating than interviews or focus groups. Participants also help in the interpretation of this data, and which leads to improved understanding of the lived experience. So this brings me to my question. In the next 125 years, how can we include a focus or take into consideration cross-cutting issues such as mental health or the inclusion of marginalized populations in our research across the school? Thank you.
Thank you very much, Micah. So I hope everyone will agree we've heard 8 excellent talks from our early career researcher community that really showcase both the diversity of the different research that's going on across the school,